Good morning, everyone. Thank you for joining us on this SkyTalks. My name is Anaelle, and I'm responsible for the strategy of Thales digital aviation products. First of all, I would like to thank ICAO for this opportunity to present you our views on air traffic flow management. In those challenging times, we believe that an efficient air traffic flow management system has a role to play to support the recovery of aviation, and that cloud-based solutions are very well suited to answer the challenges of the world during and after the crisis. There's something I would like to share with you. I recently learned that the Chinese ideogram that means crisis is actually made out of two symbols, one meaning danger and the other one meaning opportunity. These are seen as the two phases of a crisis. We need to keep on hoping in this crisis that hit aviation so roughly. And I like the idea of keeping a positive mindset, which seems to be the mindset of many aviation stakeholders, trying to get the lessons learned from these difficult times and get ready for the new normal. This pandemic, because of the brutal slowdown on aviation it has forced, can be an opportunity to improve the management of traffic flow and get better prepared when the traffic will restart, in order not to experience the traffic flow issues of summer 18 and 19. With the numerous travel restrictions and the change in passenger behavior, traffic and consequently congestion have plummeted worldwide. However, despite the situation, some ATFM-related delays remain all over the world. For example, in Europe, around 31,000 minutes of delay have accumulated since the beginning of the European lockdowns. It thus represents a decrease of 99.76% of ATFM-related delay compared to the same period in 2019. This shows that even nowadays, an efficient flow management remains essential to minimize this amount of delays. The network average cost of a minute of delay for airlines is of 100 euros. And since March, it implies that the induced cost for airlines was above 3 million euros. And that's only for Europe. The worldwide impact is much higher, of course. And in 2019, the 1.57 minutes average minutes of delay per flight, multiplied by 26,000 flights per day in the Eurocontrol area, were worth 4 million euros for all airlines each day. And airlines are among the actors that are suffering the most from this crisis. So it's more than ever a responsibility to ensure an efficient and expeditious flow of air traffic in order to reduce the inefficiencies that create costs for airlines, in order to eventually enable the faster recovery possible for them. And this will drive the recovery of the whole value chain. Looking at past crises to learn from history is always a crucial source of insights to predict future trends. This subprime financial crisis has hit the world in 2007. So you can see on this graph a feeble traffic growth in 2008 and a decrease in 2009. And suddenly, capacity was not a problem anymore. These figures are for Europe only, but the trends are really worldwide. And however, very soon after the crisis in 2010, delays jumped again to 2 minutes per flight, despite no traffic growth. So this past crisis tells us an interesting lesson. Time for improvement can be shorter than it seems, and that's why it's really the best moment to think of your ATFM solution. I like these two pictures that are very much alike. One of them, taken before the crisis, shows aircraft queuing on the taxiway, revealing capacity issues and an urgent need to optimize the available capacity. And the other one, taken recently, shows aircraft parked, engine covered. Sector overload resolution before the crisis was replaced by the optimal management of the resource in underload mode, which means the identification of the minimum service. Maximized capacity was replaced by adapted capacity and scalability, and need to be flexible, especially to scale down. Anticipation of overloads was replaced by the anticipation of the recovery of the traffic growth. But the tool that supports those needs is actually the same, a tool that provides a comprehensive situational awareness and very accurate demand forecast and an extensive collaboration. So we're convinced that cloud technology is very well suited to overcome these challenges. Indeed, comprehensive situational awareness implies integration of various data feeds. Increased predictability requires, in addition to this comprehensive situational awareness, an accurate demand forecast. And for that, the high computing power and artificial intelligence are instrumental. And collaboration requires extensive data exchanges. And for all these reasons, we are convinced that cloud is the technology that is best suited to overcome these challenges. So first of all, cloud technology enables to simply integrate various data feeds, integration of all relevant information to the flow management position, enable to have a comprehensive situational awareness and make decisions with all required information at a glance. Instead of looking at different screens and mentally couple the information, the FMP must have a clear understanding of the situation. And with computing power of cloud technology, hotspots can be pre-computed, and the attention of the FMP can be directly drawn on potential demand and capacity balancing issues or weather hazards impacting the traffic. And military airspaces is also key information to have on that all-in-one screen. Accuracy of demand forecast is the cornerstone of an efficient ATFM system. Without an accurate demand prediction, which is key to the entry count and even more to the occupancy count, no reliable plan can be made. An inaccurate demand forecast can even result in creating more hotspots. And cloud technology is well suited when high computation power and artificial intelligence are required. So at Thales, for example, we are using the same algorithms than the one used in our ATC solutions, so ATC-grade algorithms. They are used to compute trajectories out of the field flight plans and their updates. This ensures consistency with the ATC system and accurate trajectory forecast. And these trajectories are then recalibrated with ADS-B and with local radar surveillance. And this mechanism requires substantial computing power to reach that level of accuracy. And cloud technology enables to access the exact required quantity of computing power dynamically and mutualize the costs of this resource. It also enables to easily plug AI algorithm to go further in the level of optimization. And for example, the estimated takeoff time of our Top Sky flow management solution has been increased by 14% using AI as compared to classical algorithms from surveillance data providers. Another key use case of AI for ATFM is the capacity increase made possible by a smarter sectorization plan. So the key value of ATFM is to increase capacity with the same amount of resource. And cloud technology makes it very easy to integrate AI algorithm to enable smarter optimization. And out of hundreds of sector combination, AI is instrumental to find the best sectorization as well as the best plan over the entire day. Indeed, two criteria are to be considered. The first one is the optimization of each individual sectorization. And the second one is the minimization of the impact on the operational room of the transition from one sectorization to the next one. And only the combination of these two criteria enables to efficiently improve capacity. Complexity. To further optimize capacity, more advanced concepts than entry and occupancy counts may be considered. Complexity reflects more closely the controller workload. Indeed, a simple flow of stable flights within a sector will imply a lighter workload for controllers than flights climbing or descending within the sector. And then complexity hotspots can differ from capacity or entry hotspots and better reflect the potential impact on safety. And cloud technology enables to couple smart AI algorithms to compute this complexity, or a simpler one if a deterministic approach is preferred. Another key advantage of online tools is that by nature, they have the ability to break the silos of protected information on premises. A substantial share of traffic flows are worldwide, and they impact several airspaces. And an efficient air traffic flow management can't be reached without an extensive level of collaboration between ANSP. This implies sharing data with other ANSP, and that's a key advantage of cloud systems, thanks to the APIs they provide. Sharing data among ANSPs enabled to refine the entry time in the next airspace and benefit to the whole community. Several flavors of ATFM exist all over the world, and cloud technology enables the flexibility required to adapt to each of these concepts of operation. So whatever your operations, collaboration, and thus data exchange is the cornerstone of an efficient system. So domestic ATFM implemented by the FAA, for example, is best suited to large countries with intense domestic traffic. But even there, collaboration among the different FIRs and with neighboring countries is crucial. Regional centralized ATFM, that's best suited to a region where a regulator is in charge of improving the traffic flow, Eurocontrol, for example, in Europe. Information sharing with both the regulator and other members is really a must-have. And distributed regional and multi-nodal ATFM involves different countries with different maturity levels regarding to ATFM. And with cloud technology, it's possible to start with a reduced set of features and simply grow when processes are more mature. And scalability of cloud is also very much adapted to a mixture of traffic levels. And because it implies several partners, collaboration and data exchange is really the cornerstone for that concept of operation. And whatever the chosen concept of operation, to support aviation recovery, all ANSPs must minimize the penalties due to congestion, as it has a substantial impact on cost for airlines. And for that, an efficient ATFM system must provide different traffic management initiatives to enable the FMP to find the smartest one, which means that will solve the capacity issues while minimizing the impact on airlines and spreading the consequences of the capacity issues as fairly as possible among flights. Ground delay program, a very effective initiative that will enable airlines to wait on the ground engine shutdown and thus reduce the unnecessary fuel burn, but it has a huge operational impact on delay for airlines. So thus some more finer initiative must also be possible depending on the context. For example, takeoff not before, so that the same principle will apply to a single flight. That's what we call cherry picking. Level capping, a flight level restriction to avoid upper saturated sectors, or lateral rerouting to avoid laterally a crowded sector. So we've been discussing about the need to break silos between ANSPs, and that's also true for all the other stakeholders. Sharing surveillance data enables to refine the entry time in the next airspace, and when the accuracy is increased, the margins taken in the disseminated ATFM initiatives can be reduced, and this has a positive impact on delays for airlines. And airlines truly must be part of the system as a real actor. So for example, at Thales, we're currently working on further collaboration with airlines through a CSOR program that would give them the capacity to proactively protect flights from being impacted by ATFM initiatives with a dedicated quota per airline, of course. And this enables airlines to protect the flights with short connection time, and that's important for them to improve their operations during the recovery periods. Airports must also be part of the loop. Sharing the accurate ETA will enable the ramp agents to be ready right on time, not too early, not too late. Computed takeoff time dissemination is key to ensure the success of takeoff not before and ground delay measures, so it's important to coordinate with the airport. And general information sharing, such as fog, runway closure, airport capacity change, and will also drive a successful collaboration. The military are not to be forgotten, because the impact of an earlier closure of a military airspace on traffic peaks can have a huge impact. So they are definitely part of the loop, and this can start with very simple communication with the military. Cybersecurity. This intense data exchange can increase the exposure to cyber threats. So that's something we've considered from the very first design of each of our projects to ensure very high standards of cybersecurity by design. And contrary to common beliefs, the solutions that are most subject to ransomwares are actually on-premises solutions. A recent and sadly famous example is the one of Garmin, which was attacked with a ransomware that encrypted all of their hardwares, and they were targeting their in-house on-premises servers. And the reason why ransomwares are more successful on-prem solutions is that for cloud solutions, the security costs are spread among all customers, and this enables to reach much higher standards of security. So cloud providers implement stringent procedures to guarantee the security of their data centers. They also do continuous security analysis, doing pen tests and bug bounty campaigns. And if there is a breach, which can happen, the response is much faster as the patch can be deployed very fast. And I'm emphasizing on this subject because at Thales, we really care about cybersecurity. This is really one pillar of our DNA and of our activities worldwide, even beyond aviation. And we regularly conduct bug bounty campaigns on our products. So that's actually a team of hackers. We could call them benevolent hackers because they are paid by Thales, and they are trying to find the breaches in our system. So they're trying to behave as real hackers, trying to find the breach and enter the system. And that's a great way to find any breach and to directly fix any potential breach. We also selected cloud solutions because it's most adapted to the way we co-create with our customers. The FMP must be at the very core of the design of the solution. And for that, we have a team of 4 user experience and user interface managers, and they are using agile methodology to get customer needs in the project in the best manner. And as new releases are very simple to conduct using cloud solutions, you can receive a new update every 3 months, which enables to continuously co-create and innovate together. And in case a breach exists, a patch can be deployed much faster than using on-premises software, even for a functional problem. Lastly, cloud solutions are also adapted to the reduction of the budget of the economic crisis that is following the pandemic. It enables ANSPs to focus on their core competencies, which is air traffic management and flow management, and which is not IT. Computation power and cybersecurity costs are mutualized between the provider's customers and even between the cloud suppliers' customers. And by pooling these resources, cloud solutions are on the average 30% cheaper than in-house on-premises solutions. Because of the total cost of ownership that is most of the time underestimated, because it includes data warehouse, real estate costs, it includes energy bills, and they are sometimes difficult to consider. And pooling these costs yields real economic benefits. And the capacity to easily add options enables to start small with simple situational awareness, for example, and then to grow with further functionalities when the traffic will restart and when the congestion will increase. With still the insurance to follow up the North Star set by ICAO, but doing so step by step to turn the cliff into a simple stair that can be climbed very easily. During the crisis, aviation bashing has made the headlines. Thus, the ATFM of tomorrow must be scalable to enable green operations, or at least greener operations. Indeed, the knowledge of the capacity is a prerequisite to identify the moment when focus can be made on green practices. So, of course, it will never be detrimental to safety. So we need to know when capacity permits to focus on green. And at Thales, we really want to be part of this greener aviation, and we're working on tools to improve the knowledge of air traffic controllers on the environmental impacts of their decisions, because assessing this impact is the first step to reach greener operations and to monitor the evolution of best practices. So we're here to support you in the whole life cycle of your ATFM project, from the refinement of your needs to the support in service. So if you want to take advantage of this slowdown to get better prepared when the traffic will recover, the time is really now, and it will be my pleasure to present you Top Sky Flow Management Solution in further details. So thank you very much for attending this presentation. Now it's time for questions, so I will take any questions you have.